Good morning, back here at the Hall of Science. I'm looking at the review for the historical geology assessment. Whoops, that you took last week. Question number one, excuse me. We have the graph of half-life, and the question asks, use the figure to determine the age of a rock sample that contains a parent isotope. And here's the curve, as you've done this several times in class with the parent. And it's got a half-life of 100 million years and contains 1/8. And we want to know the age. Well, we know the half-life is 100 million years, so every half-life that the parent goes through or the radioactive material goes through, it's 100 million years. So we look, we got 1/8 of the material left. We take it over to our graph or the curve, go to the x, we find that it went through 3 half-lives. And so 1 half-life is 100 million, so we just multiply 3 by 100 million. And this is very, very similar to what we did in class and also your P-Lab. Question number 2 is right off the lectures. Again, we talked about in class. Figure B is a basin, looks like a bowl. Figure A is a dome because it's pointed upwards. And we know in a basin that the youngest material is in the center of the basin. When you look at a dome, the youngest material is on the outside. And we talked about Michigan be a dome and filling up with all the sediments. Question 3, very much straight definition of an index fossil. It's got to be easily identified, relatively short lifespan, and again, this could be millions of years, but it's relatively short, and it has to be widespread. And the example we used in class, the analogy we used in class, Michigan's Petoskey stone. And so those are the 3 characteristics of an index fossil. Question number 4, again going through the different strata here, historical geology, A, B, you got K, then you got an intrusion going on. Oops, K with the intrusion, then you got some erosion, C, D, E, and then you have a fault line going through. Going right through, which would be M as the fault. And we have F, G, H, and then it tilted. Again, this is that angular unconformity. And then we had some erosion Y, I, J, and then L went all the way through. Most of you are pretty good on this, so it wasn't too bad at all. Explain the difference between relative age dating and absolute age dating. Again, the analogy we talked about a cake, where in relative dating you place things in order, chronological order, from old to young, oldest being on the bottom and youngest being on top. In absolute dating, you actually determine a numerical age or a value, and you do this with the whole idea of radioactivity. Things we talked about in class, we talked about putting people in order by height. And visually, you could put them in order. And if you could actually go and measure them, that would be the absolute. The scientist that's given the credit for uniformitarianism and is also the father of modern geology is James Hutton. Little dinosaur, which is a Mesozoic extinction. What is the evidence? Well, we talked about a meteorite hitting the Gulf of Mexico near the Yucatan Peninsula, throwing up all this ash into the atmosphere, went through, caused the covered the atmosphere, and we got rid of photosynthesis, and we went through the whole idea of the plant eaters dying out, therefore the meat eaters were dying out. But the evidence is this layer of iridium ash, which is found all around the world. And I believe this is the last question. And again, here's our 3 unconformities. And we know a disconformity is erosion between sedimentary layers. So we have a disconformity here and disconformity there. Actually, there's another disconformity right there also. An angular, well, that was pretty obvious to pick out here. Whatever happens on, they're not horizontal anymore. They are shifted off to an angle, and you have that erosion going on. And a nonconformity, a sedimentary layer over the top of a metamorphic. and right here, metamorphosed Precambrian rocks, and you'd have this nonconformity right there. This is the exact sample that we, or the exact example that we used in class. So that was it, fairly short. I will get the B version of this out for those that want to retest. It'll be very, very similar. Again, like them all, not exactly the same problems, but similar content will be covered. So that is it from the Cave of Science, and we will talk to you later.